Welcome back to our wireless sensor network lecture number 3. So in the previous lecture, we have seen this WSNs, then ad hoc network, comparison of WSN and ad hoc networks. Okay, and essentially, the very basic thing is that this WSN deployment many times they are static, and ad hoc networks they are static, or maybe the majority they are dynamic. So other you will just have this knowledge of this thing. There is something called as manets. Manets. This concept is I will put. So what is manet? Mobile ad hoc networks. Okay. So this concept comes when you are having your devices, or there is something also called as VANETs, or also referred as vehicular ad hoc network. So this mainly idea is that objects are moving. When your objects they are forming this ad hoc networks, they are moving, and with a common goal, these networks are formed, and they perform the activity, communicate with each other in the ad hoc. This for that because of that purpose. In the suppose in the particular area you are having this manet or vanet active, then they are having protocols for communications, separate protocols for manets are there, mobile ad hoc networks, which actually enable this net, because there is this number of nodes there, it is highly variable, it is not constant, and nodes come in, nodes go out, these things are very common, that's why they are actually ad hoc and mobile. So or otherwise it may happen that no, this group of this mobile what you can say nodes are there, they are simply moving in the city, and in this during because they are connected to a base station, and using this internet connectivity, this connectivity, they are communicating with each other and they are moving. So like this thing, if they are moving, they should be also communicating with each other, and they should be connected, and they should be using the protocol for data exchange or data transfer. So for that purpose they have specially designed protocol. So these are also types of ad hoc network. Okay, so that is one what you can say thing that you should be actually knowing. Okay, let us go ahead with the discussion. Scalability we have discussed yesterday. Now we start with data collection. So what happens that when you say that now why we are discussing this thing, when I am now sure that we are discussing this WSN as a part of our IoE deployments. Okay, and in the IoE we are having these sensor networks now. Sensor nodes are there, and they have formed the network, and these networks are of wireless sensor network. Okay, and the purpose of that to implement a common goal for smart city applications. Okay, so some or other way you will have to work on data collection. You will have to work on data collection, because this node they want to transmit the data to a central entity which will be collecting the data and relaying to the cloud for the further processing. Okay, so there has to be some mechanism. The common goal here is that collect the data, process it maybe locally or remotely, process it, remove the noise, remove the anomalies, and that data packet should be collected locally and then uploaded to the cloud. This process may be slightly plus minus differ, that is okay. The idea is that data collection and data upload. Okay, data collection and data upload. So what are the approaches for that? So yes, there is centralized data collection. What happens that one central node collects everything and then it uploads. So it says that okay, extra button node closer nodes, the nodes to what you can say upload it. So what happens that central node is there, as I said that, or I'll say that nowadays we call that as edge node. Okay, so this edge node, central node, all the what you can say though they have to actually send this packet, send their data to this central node or this node. So what happens that if there is something relaying kind of things are work, so this what this protocol generally they are working on, do you have to relay this data to closer node. Okay, and then using this node your WSN structure, if it is static, then they will route this, what you can say, data to this node next to them. Okay, and because of that thing, what will happen, the nodes which are closer to this edge, they will have burden of collecting the data and sending it. So maybe power related issue and other thing may come. Okay, so for that purpose, maybe what the solution is, that clever routing means rather than sending organizing structure in this way, clever routing can be done, and this what you can say, the burden which is coming on these nodes can be elevated by sharing the traffic amongst the nodes which are closer. So rather than handling this data handled by these two nodes, further these three nodes can also be cleverly used to handle the problem. So the centralized data collection is one. Then clustering is what you group the nodes. So when you have what is WSN deployment, and this separate, suppose separate areas are there like this thing. So maybe this is one area, this is area. Rather than in this full region, we group this node together in some clusters like this thing. And then in each cluster, you will have the cluster, the central node, and all these nodes, they will send data to this central node, and then all these central nodes, they will be communicating with the device for uploading to cloud or your process. Okay, so group of nodes used together. This is the second approach to centralize clustering. These are the two main approach for data collection and data upload. Then, okay, what you can say, these nodes might be sending data from the sensors, or maybe their intermediary, what you can say, data coming from other nodes and uploading. And other part is that security means almost this is another major concern, is that if someone is communicating with your edge device from your deployment, it should not be someone may place some spurious node here, and it may be hacked and your system may be compromised for no unwanted data, noise data, or other security or sensitive resources they may access. Okay, so that's why these links or upload process, they have to be managed with encryption. So data is generally, it should be avoided that plain data should not be transmitted by the either central node, cluster node, or the participating nodes. Okay. Then power supply aspect. So now this is immaterial nowadays, because no this A batteries, hardly anyone uses A battery in WSN networks. Rather, Li-ion batteries are used, which are chargeable. So solar chargeable systems are there. With solar charging panels, they will charge this battery, or there are other, what you can say, powerful, what you can alternatives for that thing. But for portability and for reusability, these lithium-ion batteries are very common. Here you can say alkaline batteries offer high energy density at cheap price. They say alkaline batteries are there, and they have good life. Okay, but cost is another issue. So rather than having, what you can say, replaceable battery, one good model is there, that but provided it should what you can say, it should have exposure to sun. If your WSN network is suppose working on kind of underground application, then you have to go for no like this battery, or this lithium battery is charged by other power source, but that becomes every node has to be charged separately. Another option is fuel cells. Okay, so for this there is something called as no oxygen and hydrogen, this electric cells are there, and they this fusion is happening, and this electricity is generated using that. So these fusion cells are there, but cost and other technology curve is very high for that thing. So this, what is energy and portable energy and energy density, they are the key part that should be considered when powering your WSN deployment. So starting from no AA battery to lithium ion battery to solar cells, solar charging stations, to then fuel cells are the possible alternatives that are available. Okay. For communication standard, we have discussed that wireless bands are there. Now our 80 Node MCU, it had compatible 802.11 BGN compatibility. So typically, and it was using 2.4 gigahertz band. So you can say 2.4 gigahertz ISM band was there, and there is other bands which are also available for this Wi-Fi communication. And there is no option for this thing, because when the best alternative when it goes for large scale deployment is wireless communication only. So we have to have the system which will have this wireless communication interface. Okay. And power control already for this, no, the modulation scheme which is used by, what you can say, this uh, they are having like, narrowband FSK, then Zigbee and Bluetooth. The these schemes are there which are used for, how these devices need to be controlled or will be communicating with each other. Then CPUs are there. So this CPU part is now almost now highly advanced. So for example, in your node MCU, which is a common node, which is having Tensilia CPU with 2 cores, or rather than CPU, they also refer this as microcontroller, but they are having full-fledged CPU. Arduino has got ATMEL, this microcontroller. So there is a brief difference between microcontroller and central processing unit. So the main difference is that microcontroller is a single chip CPU. It has its own RAM, its own ROM, and it can directly interface with the hardware, and it can be flash and run. CPU, you might have to connect additional RAM to, maybe through the motherboard circuitry, and then everything comes. Then ROM, RAM, your storage has to be separately connected. So microcontrollers, they are just, no, they are specifically uh, small power, small complex, less complexity, and very versatile devices are there, but their compute capacity is low. But these CPUs, they need additional, what you can say, circuitry for these peripherals to be connected, or it's their supporting circuitry to be connected, like it has got RAM, ROM, and others. But they are having much more compute power. So for example, you can see here this Raspberry Pi, it has got CPU, it has got its own separate RAM, then it has got a separate GPU. It is much more powerful compute machine. But here you Arduino, it has got microcontroller here. So microcontroller, it has got everything. So because of this thing, Arduino circuitry is very simple, and it can address, what you can say, simpler application with much ease and cheap price. It is very cost effective. But when you want to go for Raspberry Pi, as it, you can see, it is a full-fledged computer motherboard, and it needs, what you can say, separate operating system to be this programmed and configured through this SD card. It has got, what you can say, some additional things or processing need to be done to make it operational, but the capacity can be much higher. So idea is that now this node MCU or this Arduino, they can be used as your wireless sensor nodes, and this Raspberry Pi can be used as a central node or this edge device which will collect the data and upload to the cloud. So this can be the difference. But yes, this microcontrolling unit are the 8 mega CPU is there, 128 or MSP 430. These two CPUs, they are commonly used as their microcontrollers in this WSNs, because WSNs, we need highly power effective and effective compute, and low power consumption is the very much, what you can say, requirement. So this this Atmega 128 and RMSP 430, they are very good choice as microcontrollers. For, you can say, this node MCU, there is Tensilia CPU is there. Okay, so sensors. So the sensors, in there are various categories we saw in this our first lecture: active sensors, passive sensors, then electromechanical sensors. So there is one thing called as MEMS. So micro electromechanical systems are there, which, what you can say, are used because, see, environmental entities are there, like temperature or air pressure is there. This, then humidity. So for these three one-day entities, these are example. So various sensing mechanisms are required, or different sensing mechanisms are required. So here you can use the, uh, so thermoelectric effect can be used in your temperature sensing. For air pressure, we need to use the, as this microelectrical mechanical system, where this change in the air pressure, it has to be reflected in some mechanical system. And for humidity, Also the conductivity of a material, or this no uh, conductivity between two electrodes, it changes if there is humid soil or moisture, and that current is increased when humidity is more, current is decreased when humidity is less. This phenomena is used for sensing purpose. So yes, these sensors also consume certain electricity, certain what you can say current, certain power. It should be properly managed. And this MEMS are is what you can say special. There are techniques. They minimize the size of sensors. They optimize the power consumptions and make your sensors more and more accurate, and that can be used for your WSN deployments. So applications, some of the case studies we'll see briefly. So yesterday one person asked what are the applications of ad hoc networks. So here you can see that I discussed some of the things like students, their presence on in the class and their interaction or some other applications. But here some of the key, now these are WSN applications. So specifically, or your IoE applications, you can implement your, we have seen smart home. Yesterday I give the example for a typical, then traffic management can be there, or in a specific premises how many people are coming and going, that can be one example. So here these are the other examples where military or this defense applications are there, environmental monitoring, then medical applications, and anywhere where you have to people, process, and data. If you want to what you can say go for application with this thing, is people, process, and data, is IoE applications can be designed for that. And yes, when IoE is there, this IoE will need WSNs as a part of deployment. Okay, so let us move and see this application. So this is one of the case study, this Great Duck Island, where for a typical, this is the one island where you can see now 150 sensors were deployed to relay data of temperature, pressure, and humidity to central device. So we are monitoring this full island, and then this data was uploaded. Maybe here you can see the central device is there, so all the sensor will upload data here, and then this data will be sent to what you can say central uh, device through central your cloud application to satellite link, and here internet is there, and then you can process how the temperature is varying, how the pressure is varying, and using this thing how this habitat is environmentally stable or other things can be decided. Okay, so this is one environmental monitoring project. So even one of my students, they are working on this anomaly detection using this Twitter analytics data. Then so idea is that you can see now this range of this WSN deployment. So it is very big island. So at least so you can say 10 square kilometer to 20 square kilometer, 20, so 10 to 20 square kilometer. So approximately here 2 kilometer by 10 kilometer wide. This can be seen here, and over this region you are deploying your nodes, or WSN nodes, or you can call IoE nodes. So zebra net here, environment monitoring, where these specific animals and they are tracked. So again, this can be further we have seen the application in tracking of this leopards in India. Also, we have seen this thing when leopard leave their residence and they come into the urban territory. So they have to again send back to their own. So to see how they are moving, these WSN networks are there. So they are having GPS enabled collars, and they monitor the path of the this vehicle. So if you go through this part of this animals how they move, and if you go on the National Geographic or Animal Planet channel, so such case studies are frequently presented there. So they are monitoring snakes, they are monitoring lions, and how they change their habitat, how they move over the period of 1 year, and the study is presented. I'm sorry for that. Yeah. Then medical application. So health monitoring is there. I have discussed this thing in here ID parts. So what are these identifiers in IoE? So that one smart watch and its case study we have seen, where this Bluetooth connected watch and then vitals of a person, they are monitored, and this data is remotely uploaded on a cloud service, and this doctor can actually monitor the real-time vitals of their patients. So they are actually extending this to 130 node network of resident in old care facility, and all these senior citizens, their vitals are monitored centrally. Yeah. So yeah, we'll stop here. But next lectures, these things, I'll just briefly initiate that. Then we'll discuss it in next lecture. So idea is that now data dissemination thing. So this briefly we have discussed. So what happens? We are seeing this now duck network, duck island, where on very big area of 20 square kilometer, these nodes are there. So obviously this one single node, suppose this is almost 10 kilometer by 10 kilometer, not meter, is there, and suppose at 3 kilometers you are having your no central edge device is there. So this node is not having no deployment, this communication range of 3 kilometers. It can maximum communicate to 1 kilometer. So what we'll have, we'll have we are having now this node deployed here, maybe uniformly we can say to monitor the environmental condition. So how to make this data from node X to this node E, how this should be reaching? So for that purpose, we have to design the data dissemination schemes. From one point to other point, how this data will reach. Can it reach directly? No. Then single hop, multi-hop, direct communication or wireless communication, how it is possible? If it can't reach directly, that is the problem. So how to address the problem? Using the various protocols which WSN use for communication purpose. So that we can discuss in the coming, that will be discussing in the coming lectures. So I'll stop the broadcast.